Yeah, we're trying vertical, remember, because theoretically it goes into the shorts. So sorry, but it'll be fine. Um, I'm not ready for this at all, so give me 1 second. I need to get a laptop. Not very prepared, as always. No, I was trying to make thumbnails where I'm trying to do the ACT videos as well. And I got caught up with doing that. My nap only lasted till like 6:40 or so. Can we go back to horizontal? Maybe, but no. We're gonna try it out. Maybe we can get strangers to watch. That's the goal. Um, so obviously we're doing Taylor Series bricks today. I just want to pull out a Taylor Series packet and stuff so I can sort of base it off of that. It won't be the same ones as like college board ones, but I can sort of modify them. So give me 1 second. I'm almost done. What do I want to go? I want this thing, right? I want this. Okay, sign me into that. That's the wrong website. Um, yeah, but sometimes even if you there's two AP exams, so maybe that person hasn't taken the BC exam, so she might be able to learn something, you know? Okay. Okay. Let's start. Let's start. Okay. All right, we're starting. Let's do some Taylor Series bricks. So, Taylor Series bricks. So, this first one is going to be, remember there's three types of Taylor Series fricks. They come in three varieties. So we're gonna do the one that is probably the one I like the best because I'm trying to gain my sort of sense of direction here. So let's start. These are the givens. Just making this up off the top of my head or basing it off a previous brick. So we have this, n equals 0 to infinity. Let's put some negatives in there just to make things a little bit spicy. I also want, what do I want? 2x, 2n, x to the n over n plus 1. So this is my Taylor series. And then they would give the general, so just let's practice just plugging in the numbers. They would usually write out some terms. So if we plug in 0, can anybody do that? I think you get 1. Okay. Did anybody, is that true? If you plug in 1, I think you get, somebody help me over here. Minus x, maybe? We're doing a Taylor series brick where we're trying to write the question, but obviously I'm not prepared, so we're just practicing plugging in these Taylor series so that I can actually start the question. So when you plug in 1, you get 2 times x over 2. So I think it's minus x. We haven't even started the question, buddy. And then we're going to plug in 2. So it will be x squared, 4 over 3x squared. Okay, I can't do math. And then minus 8 over 4x to the third, I believe. Okay, we're ready to start. So this is the Taylor series, and the first question you can practice. The reason why we're starting off with this question is because we're doing a big question. We're going to find the interval of convergence of this Taylor series, this Maclaurin series. Notice it is a Maclaurin series because we're centered around 0, as there's no like x minus a number. So find the interval of convergence of the Maclaurin series. I think we lost the strangers, but that's okay. Of f. Cool. Do you want to try it yourself or no? Yeah, try it yourself. It's an interval of convergence question, one of the biggest questions in Taylor series. If this is on the free response question and it's straight up find the interval of convergence without being given a radius or without just finding the radius, you will probably it'll probably be worth 5 points. And remember that the last step of this is actually the least important step, so just be wary of that. I'll give you like a couple minutes as I just talk about Taylor series bricks in general. So there's 3 types of Taylor series bricks. I call this the interval of convergence brick because the part A is finding the interval of convergence. And also, when you find this interval of convergence, it's usually worth 5 of the, or 6 even points out of the 9 points. So that's why it's such a big bulk, which is why I sort of delineate it as a certain frick. And then the second type of frick we're going to try to practice as we do this is when they give you a derivative formula. And then the third type of Taylor series frick is when they give you a special function, usually e, sine, or cosine, where you would have to memorize those functions, and potentially ln, or maybe inverse tan, maybe, or maybe a geometric one. So those are the 3 main types of Taylor series fricks. Further on, as we do these questions, as we'll be taking derivatives at some point in all 3 types. We'll be doing geometric with rational function. We might be taking integrals. We might be going from one Taylor series to the next. Hopefully you know that in this question, we're not going to use the factorial formula for Taylor series because we're already given the general term. So we're not going to write the derivative over 5 factorial x blah 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 to the 5th sort of thing. We're just going to go straight from this Taylor series to what we need to do. And that's how it works for this frick and also the special Taylor series function frick. The one where you actually are doing factorials is the derivative formula. But that's enough talking today. I'm going to start doing this with the ratio test. So when you set up the ratio test, they're looking for you to set it up correctly, which involves doing absolute value, unfortunately. Remember that you don't bump everything up by 1, even though that's the case in here. You actually plug in n plus 1. So I'm going to plug in n plus 1 here. That's why it's n plus 1, which is n plus 2. Then I flip it because I'm dividing by an. So let's flip this guy. And then I start canceling. So this would be worth the first point, just setting up the ratio. Second one is to start canceling out. So there's a lot of things here to cancel, and let's just go slowly as we cancel them. Because we have absolute value bars, I'm just going to completely ignore this negative. Then I have end to stuff, and that just cancels because it's same heavy. And then finally, I need an n plus 1 here, where you have to cancel these exponents. If I make a mistake, you can definitely call me out because I am theoretically known to do that. So these exponents, we have 2 to the n plus 1 over 2 to the n, and that's going to cancel because we'll have one more 2 on the top than the bottom. So we'll have a 2 left after these 2's cancel. And then finally, x to the plus n plus 1 over x to the n will be the same thing. We'll have an x left. And because it's absolute value and we don't know what the x value is, we are going to write it in absolute value. So we have 2 times the absolute value of x here. And remember, what we do is we always say it's less than 1. So this is the result of the ratio test. This would be worth 3 of the 5 points because I set up the ratio test and I found the result. And then what you do is, unfortunately, we're finding interval of convergence and not radius convergence. Let's first find radius convergence. Remember, you're always isolating like absolute value of x, or absolute value of x minus c if we're not dealing with a Maclaurin series. So I'm going to bring over this 2, and we get 1/2. And then as one person in the chat said, plugging in is the hardest part because we have our center point 0, and then we go negative 1/2 and 1/2. So let's go slowly as we do that. Remember, that is the least important part, so don't feel too bad if you can't do that. Because that's only worth 1 of the 5 points, but we're still going to try our best. So I like always plugging in the right endpoint first into my general, and keep in mind you're always plugging in into the general. So I'm going to do that real quick. When you plug in the right side, you'll get less negative things, so that's why I like to start off with that. So I'll have 2 to the n times 1/2 to the n over n plus 1. So when you do this, just keep in mind that a lot of things are going to cancel. Yeah, so this is the considering. So even just attempting gives you 1 point. So the actual answer of like converge or diverge at the endpoints, bracket versus parenthesis, is only worth 1 point. The negative ones, I don't even have negative ones. That's on the left side, I think. I'm going to do the right side first. So again, when you're doing this, a lot of things cancel if you're very careful. Like this 2 to the n and this negative 1 over 2 to the n will cancel. No, drawing the line doesn't give you a point probably. You have to actually write what you think are the endpoints. So I think the endpoints are negative 1/2 and 1/2, and I'm considering them now. So what you're going to do is these 2's cancel. So you're left with negative 1 to the n over n plus 1. And this is a pretty famous series. Remember, you don't have to go too crazy when you verify these series. This is an alternating series over a p series. So it's an alternating p series. And what's the p? It's going to be p equals 1. That's going to be a harmonic series. So this is just converged by AST. So that's that. Again, when we plug in the left side, unfortunately, that's going to be the worst side. So we're going to plug in our negative 1/2 again into this x right here. And I always do this very carefully because I think I'm going to mess up this sort of simplification. And really the crux of what I'm doing is that I always break up a number as negative 1 times that number, or that positive number. So because I want to just have everything interact with sort of its counterparts. So I'm going to take this negative 1/2, and negative 1/2 to the n is the same thing as negative 1 to the n times 1/2 to the n. So I'm going to break it up. So it's negative 1 to the n times 2 to the n times negative 1 to the n times 1 over 2 to the n. And then this is all over n plus 1. And by breaking this up, I'm able to simplify this way more easily. For example, these 2's will just cancel because 2 to the n divided by 2 to the n, or 2 to the n times 1 over 2 to the n, is just 1. And then because I was able to break the negative from its number, I'm able to now combine these negative 1's. And I'm using an ACT rule now, or an SAT rule, where negative 1 to the n times negative 1 to the n, if you have the same base, you add the exponents. So then we're going to get negative 1 to the 2n over n plus 1. Sorry, I ran out of room here. And then as you do this, you have to keep going. So again, this last point has been very hard to get. But negative 1 to the 2n, you want to decide whether that's always negative, always positive, or alternating. And negative 1 to the 2n, because 2n is even. 2 times a number is an even number. So this is always going to be negative 1 to the 2, or negative 1 to an even power. So that's going to be 1. So you're going to be left with this. And this is just a p series, or the harmonic series, because it's p equals 1. That diverges. So as somebody in the chat said, I believe she is correct, or he or they. The answer is negative 1/2 parentheses, because it diverges on the left side, comma 1/2 bracket, because it converges on the right side. And that is how you do interval of convergence. So again, it is a quite annoying question, but it's a long question where you can get a lot of partial credit. I think it's 1 point for setting up the ratio test at all, 1 point for getting the conclusion of the ratio test, which is this result right here, 1 step for finding the r, which is dividing by 2, 1 point for considering the endpoints, and then actually doing it. So hopefully that makes sense. We will definitely do Lagrange at some point, error bounds and things like that. But hopefully, let's move on though, because it has been a little bit of time. So let's cover this up. So we found the interval convergence. Again, that would be the bulk of this question. Now let's try to do sort of sort of questions that they would ask. So for example, what they would ask probably is find the first three non-zero terms and the general term for f double prime of x. So sometimes in Taylor series bricks, the part A really relies on part B, part B really relies on part A. But in this case, that's not true. Interval of convergence is its own like really independent question. So when we're doing this derivative, we're just going to look at our original question. Try to take the derivative for 1 second, please. Just keep in mind that when you're doing this, anytime you're doing derivatives on Taylor series and integrals on Taylor series, it's the simplest integrals and derivatives that are possible. You only do the power rule. You don't do chain rule. You don't do U subs when you're doing these integrals. It's always just power rule. So it's actually a pretty simple question. So I'll give you a chance to do that. You also have to take the derivative of the general term, but usually keep in mind that that is, we'll talk about that later as we get there. So we have this. Okay. So I'm going to take this derivative now. So again, all it is it's derivative term by term. So the derivative of 1 is 0. I'm not going to write that. The derivative of minus x is minus 1. The derivative of 4x cubed plus x squared. I'm doing power rule, so I'm just taking the 2, dropping it to the front, subtracting 1. So it looks like it's going to be 8 over 3x. And then I'm going to have this 3, and I'm going to drop it again. So it's going to be minus 8 over 12, I think, because 4 times 3 is 12, x squared. So those are my first 3 terms. And notice how simple it was. It was just taking derivatives. Some people have struggle more with taking the derivative of the general term. So let's practice that. What I tell my students is, why don't you do the factorial thing? Okay, 24 thirds. Give me 1 second. Oh yeah, so if you're taking the derivative, you might as well do it correctly. When you drop the 3 down, the 3 doesn't go in the bottom, of course, it goes into the top. So somebody is correct. This should be 24 over 4. Let me rewrite this so nobody will remember my past mistakes. So I dropped the 3 down, and it's negative 24. And negative 24 over 4 is 6, so it's just negative 6. That was kind of embarrassing, but, you know, sometimes the past comes to get you. Okay. So we have this now. I think we finally have the right derivative. So I'm going to take the derivative of the general term. So here's the general term right here. Again, when you do whatever you did to the first few terms, you should do to the general term. So what I'm going to do is I'm going to take this monstrosity of a thing. I keep in mind that all of the things that are not x's are like a constant. So it's like the 8/12 or the 8/3 from before. And then all I do is I take the exponent and I drop it to the front and let it cancel. So let's do that. So when I take the derivative, I'm just going to have this random big constant. So it's going to be negative 1 to the n times 2 to the n over n plus 1. And then I'm going to bring down my power. So it's going to be x. And then I'm going to subtract 1. So it's x to the n minus 1. Cool. So one person earlier asked a very quick key question, which is why not use the factorial formula that Taylor series is famous for? And the reason why you don't do that is really the main question I like to ask my students, or have them ask themselves as they do every single question. So the main question you want to ask yourself is the following. Do I create my own Taylor series, which is using the factorial formula that was referred to, or do I go from one Taylor series formula to the next? So it's all about the givens. If the given is a Taylor series itself, so this is a Taylor series with a general term, you're probably not doing the factorial formula because you already have a Taylor series already presented to you on the page. So when you're taking derivatives or when you're taking integrals, you probably go from that original. Same thing with the opposite. So we're going to practice a frick later on in the stream where we're given a derivative formula where we won't see a Taylor series. So the very first thing we'll probably do is use that factorial formula. That factorial formula is used to create the first Taylor series when you're doing these fricks. So sometimes you have to create it on your own, but sometimes it's already given, so you don't have to do that. Hopefully that makes sense. You're given the general, you're given a Taylor series, like you're given terms. So it's definitely the Taylor series is given. So then you don't have to do that. Hopefully that makes sense. Let's move on and let's just do one little thing on this brick and then we can move on. So let's see. So how do they word it? Let's just make sure how they word it. Why is there no questions? Let's see. Yeah, let's do this. Let P2, Pn. So this is part C now. So let Pn of, let's say, 1/2 represent the nth degree Taylor polynomial like normal. Let's see, use alternating series bound. So usually in these questions, after you do your Taylor series, you might have an error bound question. And again, you're probably using your previous steps. I'm not sure how long we're going to go. Theoretically, the Grizzlies start at 9:30, so I'm willing to go till 9:30. You know, because we should support the Grizzlies. But we're going to do f prime. So we're basing it off the previous question. F prime of 1/2 minus P2 of 1/2. And then give me 1 second while let's do, we can do P2. So this will be a little bit trickier. Let's see, give me 1 second. So we need a next term here. So as we create this term, this would be 5/16, 1/2 x to the 4th. So its derivative would be 30. Whoa, that's a weird number. This is not a good question. I should have created a better question. Let's not do this actually. Okay, so let's just do P1. That would make it easier. 1/2, 1/4, 6/4. Let's just say it's less than 1. Okay. So this is the error bound question. So anytime you're doing error bound questions, remember that the format is S minus Sn is less than Bn plus 1. Yeah, this is not the greatest question that I've ever created, but we're gonna roll with it. So this is error bound. This is the impossible thing. This is the error, and then you always use the next one over. So if you're looking at this right here, so remember that when you're doing these error bound questions, you're probably using an answer to a previous subpart. So we're taking our answer that we found earlier, and what we're going to do is we are going to do the next one over. So Sn is P1 here, so the next one over is B2. And keep in mind, this doesn't mean the second term, this is the next one over. So this is the first one, this is the second one, and because we did SP1, you go up to the x1, so that's going to be P1, and then you do the next term over, which is this term right here. Hopefully that makes sense. And then what you do is you just take this term, you don't include the negative, so I'm going to write 6x squared, and then all you do is you plug in 1/2. So it's 6 times 1/2 squared. Also, we need to change our number to 2. So then this is going to be 6/4, which is 3/2. And then you hope and pray that your number is smaller than the number that they want, which we changed to 2. So the answer is correct. So does the 1 refer to the degree then? Yes, because it says let Pn represent the nth degree polynomial, so you plug in 1. So it's the first x to the 1. 1/2 is the number you plug in. Why are we using the derivative? Oh, it's because the error bound will be on a question. So because it says f prime, we have to use f prime. We have to plug in f prime. If it was f, we would be using the original f here. but it's whatever you have. So usually the questions, the way this works is they give you f of x is given, and then you find g of x, or you find f prime of x, and usually the error bound question is on the second question as opposed to the first one. Hopefully this makes sense. This wasn't my best work, obviously. The really big thing that we focused on was the interval of convergence. But I think if we move on and to do a special series brick, I can redeem myself in terms of my teaching ability. Can we move on to the next brick, or? So I'm going to move on. Okay, so let's move on. Watch this. Please believe in me. So let's do this. Let f of x equal something crazy like x cubed e to the 2x. So our first question is write the first four non-zero terms of f of x. And let's just go crazy and find the general one as well. So the general one will be a little bit harder. So you can try this question for yourself. But again, if you're really focused on whether that big question of do I do the factorial or do I not do the factorial? Again, here we have f of x. So we're probably not doing the factorial formula because we don't know anything about the derivatives. We're probably going to go from one Taylor series to the next as we're going to practice. So you can start off with this one. Unfortunately, in this question, you're not able to get this question correct if you don't know the Taylor series for e to the x to start off. That's why it's nice to memorize e to the x, sine of x, and cosine of x. Let me my chair. And let me get some water. So this is frick 2, by the way. This is called a special Taylor series function frick. Right when you see sine, cosine, e to the x, you're good to go. So let's do, let's write this. Let's start this. So e to the x. Yes, e to the x has the best Taylor series. That's why I was the most comfortable doing it. You don't have any, there's no alternating thing. It's just the positive ones, and it's every single exponent. So you don't skip any. It also, I don't require my students to memorize the general term, but this one, the general term is pretty easy. All it is, it's x to the n over n factorial, because again, you don't have the negative thing and you don't skip any it. So there's that. And then now we have to find the Taylor series for f of x. So chat, I don't like using that word, but chat, do you deal with x cubed first or 2x first? We should probably do it in 2 steps. Two x, yeah. So you always plug in first. So let's plug in. So when you plug in, just be wary. So I'm going to do it again in 2 steps. When you plug in, notice that I'm plugging in all 2x for all these x's. So the first term doesn't get affected because it's not an x. So I plug in 2x, and it's just 2x over 1 factorial. But when I plug into the next one, just keep in mind that the 2x is getting plugged in, which means that it needs to be squared. So the answer will be 4x squared. Same thing with the next one. When you plug in 2x, it's going to be cubed. So it's going to be 2x cubed, which is 8x cubed. Some people struggle with the general, but again, if you do whatever you do to the originals, like the first 4 terms, to the general, you probably will get it right. So what did we do for the first 4 terms? We plugged in 2x. So what are we going to do for this one? We're going to plug in 2x. So it's going to be 2x to the n over n factorial. Let's move on. Now our goal is to find x cubed. So what we're going to do is we're going to multiply everything by x cubed. So it's going to be x cubed times e to the x 2x. And unlike the first one, when we plugged in and the first term wasn't affected, now this one does get affected, the first term, because we're multiplying by x cubed. So really we're thinking about distributing x cubed as if it were a polynomial. So it's going to be x cubed And then when you multiply by x cubed, just keep in mind that our ACT rule, so it's going to still be 2 because that's not affected, but x times x cubed would be x to the 4th. You add the exponents. X cubed times x squared is not x to the 6th, it's x to the 5th. When you have the same base, you add the exponents. So it's 4x to the 5th over 2 factorial plus 8x to the 4th, 6. Because you add the exponents over 3 factorial. So those are the first 4 terms. Then you, again, whatever you do to the original, you do to the general. So I'm going to just take this thing and I'm going to multiply this one by x cubed. So 2x to the n over n factorial times x cubed. And that is the answer. Hopefully that makes sense. Theoretically, you can simplify it if you want, but I don't know if we'll have questions that will deal with it. So we can get started. We'll try to do a Lagrange. Sometimes it's hard to write Lagranges, but I'll try my best. But let's practice this. So sometimes you do the special Taylor series function. So we did f of x, and then you like sort of work with it. So for example, in the next one, what we're going to do is we're going to find f prime of t cubed. So that'll be the first part of part B. Do you always need to write the general term? If they ask the general term, you need to write the general term. I don't think you should memorize the general terms. You can theoretically create them. This one was just easy enough because it's just, there's no negatives. But usually they would give it to you theoretically. But we have f prime of t cubed here, so we're going to try to find that Taylor series. And then we're going to go crazy and we're going to take the integral of this to find the Taylor series for g of x. And again, as you're doing this, just be careful. Just do everything step by step. Just like how we did the first one, we plugged in 2x, and then we multiplied by x cubed. We didn't try to find f of x all at once, like finding x cubed and e to the 2x. We did it step by step. We plugged in 2x and multiplied by x cubed. So in this question right here, when we ultimately want to find g, we need to slowly work our way to g. We're not ready for g yet. We're going to write the first 4 terms for this as well, so we don't have to deal with the general. So let's do this. Let's go slowly. So again, I need to first find f prime, then I need to plug in t cubed, then I have to take the integral of that. So that's going to be my thought process. So I'm going to first find f prime, then I'm going to plug in t cubed, then I'm going to take the integral. Okay. Yeah, it's the reason why it's t is because you have to do the integral with t's so they don't match. First 4 of g of x. Yeah, let's first find first 4 of g of x. So let's go. First, remember the derivative should be easy. It should just be power rule. So the derivative of x cubed is 3x squared. The derivative of 2x to the 4th is 8x cubed. 4 over 2 cancel, it's just 2. So then I think we're going to get 10x to the, 10x to the what? 4th? And then 8 over 6. So when we drop the 6 down, what's nice is that 6 and the 3 factorial will cancel because 3 factorial is 6. So I think we're left with 8x to the 5th. So that should be my derivative. Make sure I did that right because some people claim that I've made mistakes. I don't remember any of those moments, but you know, you never know. Okay, so then again, we're going step by step. So we found f prime, and now we're going to find t cubed. So this one is actually kind of hard of like knowing exactly what to do, but hopefully it makes sense that we took a derivative and then we plugged in t cubed. So we took a derivative and now we're plugging in t cubed. So when we plug in t cubed, let's do it in 2 steps. I'll literally replace all the x's with t cubed. And now we're going to use a different ACT rule. Sorry, I'm running out of space. Which is that if you have an exponent to an exponent, you multiply the exponents. So let's simplify that. 3t to the 6, because it's 3 times 2. T to the, what is this number? Third, so it'll be t to the 9th plus, now my t's and my pluses are really similar. 10t to the 12th plus 8t to the 15th, I think. So now I plugged in t cubed. Then I'm going to take the integral. Again, I'm working step by step by step. So I'm going to take this integral, and I'm going to be very careful. They want me to find the integral of f prime. I found f prime here, so I'm just going to replace it with here. So I'm replacing this. And then finally, I'm going to take this integral. It's again going to be power rule, so let's do it right here. I'm going to be careful with the t's. So remember, you add 1 and flip. So it's going to be 3 over 7 t to the 7th. Then it's going to be 8 over 11, 8 over 10, I think, t to the 10, t to the 13th now. And then finally t to the 16th. That seems right. So that's the integral. Unfortunately, I still have to plug in x and 0, but all that does is change all the t's to x's. So I'm going to go on my next page here, the magic of technology, and we're going to write out this answer, and we're done with this question. So I think we can write pretty tall here. So this is the answer to part B. And again, it was kind of a intimidating question. No, you don't need the plus dot because we're just finding the first 4. And I'm not simplifying these numbers even if they are simplifiable. Yeah, so like if they asked like first 4 terms and general, then you would probably put dots. But if they're only asking first 4, you can just write the first 4. Okay, so let's move on because again, these questions do take a while, but hopefully you saw that we went step by step. We took a derivative, then we plugged in t cubed, then we plugged in g of x. We didn't skip any steps. And as we took the integral, we just did power rule. Okay, so let's do the next question. So this is going to be part C. It's going to be a 2-parter. Use the first 2 terms to approximate g of 1. And then after that, we're going to show the approximation must differ from g of 1 by, this one we can do 1, by less than 1. Okay, so this is going to be our question. So hopefully you know that this is definitely error bound probably, like it looks error boundy. Oh, I don't think this question is actually valid because we don't have the negatives, but we're going to just pretend that it is. Yeah, we don't have the negatives, so there's no way this is right, but we're just going to pretend that there's the negatives and hopefully nobody will care. Okay, so basically when you have these questions, we don't have the alternating, so this is invalid actually. We can't do alternating series bound, but we're just going to pretend that there's negatives. So when you do alternating series, like when you do error bound, it's called the alternating series bound, so there needs to be negatives. It has to alternate, but our thing doesn't alternate, as you see. Okay, this is don't be sad. Should we make a valid question or should we just work with this? I'm willing to work with this, but if you want to make a valid, can we just like do Lagrange? This is I wanted to work with this. Okay, so we're gonna do this. So again, all it says use the first two terms to approximate g of 1. So what you do is you're going to plug in 1 into this term and this term, and you're going to try your best and add the numbers. Cool? So again, when you approximate the first few terms, what you do is you look at it says the first two, literally the first two. So you take your first two terms and you plug in the number. Thankfully, it's 1 because if it wasn't 1, it would be very difficult. And we just try to add these numbers. So let's do that first. G of 1 is approximately. So keep in mind, this is not the error bound part. The error bound part is the second part of this question. The first part is just plugging in 1. So I'm going to plug in 1. So it's 3/7 x to the 1 plus 8/10. Sorry, 1 to the 7th. My work is getting worse and worse. 1 to the 10th. And then we're going to add these two numbers. And unfortunately, this is non-calculator. So you're just going to have to try to, as best as possible, to add these numbers with a common denominator. So you multiply everything by 10. So this is 30 over 70, right? This is, what's 8 times 7? 56. So then we get 186. I don't know, I said 1. So this is the answer to part 1. Use the first two terms to approximate g of 1. Can you write the SN? Yeah, but we're not ready for that. That's the second part. So the second part is the error bound. So it's S minus Sn is less than Bn plus 1. So let's think about it. What is the impossible thing? The impossible thing is g of 1 because we're not going to plug in 1 to an infinite number of things. So that's the impossible thing. And then what is, how many terms did we use? We used 2 terms. So I'm going to call this S2. And then we look at B3. If you want, what is S2? We actually found it. We found the approximation. S2 is this number right here, 86 over 70. So now we need to find B3. And again, what you do is you look at the next term over. So we used the first 2 terms as we were doing this. We plugged in 1. So the next term over is this thing right here. So this is where the error bound comes into play. It's the next term over, which is this. And then we're going to plug in 1 now. So it's going to be 10 over 13th, 1 times 1 to the 13th. And then you get 10 over 13. And then you hope and pray that it's smaller than the number they want, which is less than 1. Good job, random stranger, that you got it. But again, what you do, this was a 2-part question. Sometimes they don't ask this first part, so just be wary of that. Or they asked it in a previous subpart. So when you're, to find the actual approximation, they'll tell you how many terms to plug it in. So I plugged in 1 into the first 3 terms, because they told me to do that. And then when you do the actual error bound of like the, why must this differ, blah, 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 you look at the next one over and you still plug in the same number. The reason why this is wrong is because this formula S minus Sn less than Bn plus 1 only applies to alternating series, and this series I created was not alternating, so theoretically we're not allowed to do it for this, but it didn't actually matter. Like, we would do the same thing. It's not actually valid to do this question. The answer is like finding this 10/13 and saying it's less than 1. Or really the work is all of this. Probably the 10/13. The error bound is 10/13. Do we need to sub the number in for S2? No, you don't. They're really looking for this term right here. I mean, it's nice to know that S2 is what you just found, but you don't have to do that. They might actually already have that in front of you. But I don't write that one. I would write S minus Sn is less than Bn plus 1. I like to write the formula down every time. And then if you're writing it in the most general way, I would write S minus S2 at least is less than B3, and then I'd write 10 over 13. To be honest, I'm not an AP grader, so I don't know how much they would want. But it probably is better to replace the S with G1, the SN with S2, and so on. But I think we're good for now. I'm really when I grade stuff, I'm looking for this number. Okay, let's keep moving on because it is 47. Let's do the third type of frick. And the third type of frick looks like this. So, given, all right, we'll do this number later because my mind is not working right now. F prime of 1 equals negative 2 and F. Times n factorial over 2a 3j. Okay. For all n greater than 2. Okay, so this is the next frick. Okay, so one of you, I think your name, I don't remember your name, because you're a bunch of strangers, right? But one of you asked, when do you do the factorial formula? And this is when you do the factorial formula. I haven't even written the question yet. The question is going to be, write the first 4 non-zero terms. And the general term. For x equal 1. So this is going to be the question. But how do I know that I'm going to do the factorial formula that we haven't used yet? And it's because they give me a derivative formula. I don't see a Taylor series. Does that make sense to everybody? I have, they give me this derivative formula. I don't see a Taylor series. I don't have like terms. I don't have a general term or anything like that. It's not Maclaurin because it's about x equals 1. And it was like I didn't have words, but it would say the function has a Taylor series about x equal 1. Like there's more wording in these questions. Okay, so let's start. So anytime I do Taylor series questions, I write out the formula. So I'm going to write out the general formula. F of 1 plus f prime of 1 over 1 factorial x minus 1 to the 1 plus f double prime of 1 over 2 factorial x minus 1 squared. I need 4 terms, unfortunately, so I keep going. This is where the vertical is sort of hurting us because we're running out of space. So I'm going to do the general on the bottom here because I do have to do the general. Okay, so that's it. Okay, so then, are we ready for this? We have the Taylor series formula, and now we're going to use these derivatives to find the Taylor series for our specific question. Notice they give me f of 1 is 3, so I'm going to use that real quick. 3 plus, then they give me f prime of 1, so I'm going to use that as well. Replace f prime with negative 1, so let's write that. And then I don't have double prime or triple prime. So I'm going to use this formula right here to find double prime or triple prime. What's the difference between this problem and the very first problem? The very first problem, they already gave me the Taylor series. I already had x's in the given. And this one, I only have the derivative formula. So I do not have a Taylor series. So I have to create the first Taylor series, which is why I'm doing this formula. So now we're going to plug in. And when you find these derivatives, remember you're plugging in the derivative number and not the center number. So I'm going to do f double prime of 1 on the side here. So right here, you plug in 2. It's going to be positive. It's going to be 2 factorial over 3 squared, so it's going to be 2 ninths. Let's do f triple prime because I also need that as well. It's going to be negative because it alternates. And then it's going to be 3 factorial, which is 6 over 3 to the third, which is 6 over 27. I'm not going to simplify anything yet. Okay, so now I have these two things, so I'm ready to create my Taylor series. I've already started. I've already done the first 2 terms. I'm going to replace f double prime with 2 ninths. And then I'm going to replace f triple prime with negative 6 ninths. Or it's negative 6 27ths. And those are my first 4 terms. Again, if you write out the Taylor series formula and then you write the derivatives, it becomes easier, in my opinion. Unfortunately, I do have to find the general, but remember, whatever you did to find the derivatives, you find the general. So what we did is we found the derivatives using this formula. So I'm going to do the same thing. I'm going to take this giant formula and I'm going to replace it with the Fn thing. So it's going to be plus this giant thing. So right here, this should be n factorial, of course. But right here, I replaced that with the formula because that's how I did the derivative ones. So I still have to divide by n factorial because all of this thing was the formula, so I replace it right here. And it's x minus 1 to the n. How did you get to the general? Yeah, this is what I'm doing right now. This is the general for every single one, the n factorial n, and then I'm just replacing this numerator here. It will be nice to simplify for the next question, so I'm going to do that. Notice these n factorials cancel, and you'll be left with this. Cool. Checking MBA scores as you write this down. All right, let's move on. So next question. Hopefully that made sense. This is a very key step. Writing the factorial formula, and again, we're doing this as opposed to the other questions because we're given a derivative formula. We're not given any Taylor series, so we have to create the first one. And then when you do this, you plug in the right derivative number to find the numerator of these coefficients, and then you plug in. You won't have to cancel out the n factorial, so this could have been a valid answer right here. But the next question, I'm going to have to do it, so I just already did it because I know what I'm going to ask in the next question. But you could have left your answer like this. But let's use our bit more basic guy. So our next question is just going to be find the radius convergence. So B will be find the radius convergence of this Taylor series. So B is find radius convergence about x is equal to 1 of the function f. So this is also a very key thing, is that in Taylor series FRQs, a lot of times you use your first subpart to do the second subpart, especially if you're finding the Taylor series as you do the first question. So because we found the Taylor series, this was the first 4 terms, 1, 2, 3, 4, and this is the general term. We're about to do radius convergence. And the main mistake students make, and unfortunately, if you make this mistake, you really can't get many points, is that they'll do ratio tests on this thing right here, the derivative formula that was given. I'm not going to really look at this derivative formula anymore because its purpose is done. It was used to create the Taylor series. And once I have the Taylor series, I should be focusing on this. So when I do the ratio test, I'm going to do it on this thing, and I'm not going to do it on the derivative formula. Does that make sense? That is a very key step. Like, do not do the ratio test on this. This has no x's. You wouldn't be able to get like x minus whatever. You have to do it on this. So, and we are just finding radius, which is great because I just have to do the ratio test. So I set up the ratio test as follows. So this is the ratio test. And again, I set it up on my general. So this is why one of you asked, do we have to simplify the general? And again, you don't have to simplify it for part A, but doing the ratio test will be way easier if we did simplify these factorials, which is why I did that. And we're doing it on this. So this is the ratio test. I did it on this general term, and now I start canceling. Hopefully you know how to cancel, because that's the most important part when you're doing the ratio test. So just keep in mind when you do this, the negatives cancel out because of the absolute value. You don't have to worry about them at all. Then I cancel out the 3's. If you don't know, 3 to the n over 3 to the n plus 1 is just a single 3 on the bottom because you have one more 3 on the bottom. And then x to the minus 1 to the n plus 1 over x minus 1 is x minus 1. That's true. So somebody already in the chat got it. Remember that you're always isolating this. You always say it's less than 1. The key is that never distribute the 1/3 or whatever. You always just bring over the number. So as people are saying in the chat, x minus 1 is less than 3. That is the answer. Remember that they don't give you more credit if you do more work. So because they just asked radius, we are going to stop here because we're not going to find interval because they only asked radius. Yeah. Should we do error bound again? There's so many error bound questions. Yeah, let's just do error bound again. I'm not sure how longer we're going to go. The other part, there was no other part. It would just find the radius convergence so we were done. If they asked interval convergence, we would have to do interval convergence, but they didn't ask it in this case, and I don't really want to do it. So if you were to find the interval, it'd be 1, 4, -2, and then you would try to find interval. I'm reporting. Okay. So I don't even know what to do for this one. We already took a derivative. We already took an integral. Let's just do error bound again. Just keep doing error bound. Keep doing error bound because that is the hardest thing. So when we're doing error bound, we won't need the radius. So we are going to use the first two terms to approximate f of 1.1. And then the second part is show the approximation is within, we're doing the first two terms, so 1.1, give me 1 second as we do this, 1.1, 0.1, 1/10, 100, 1/900 works, I think. So let's do 1 over 800. So this is error bound. Okay. So when you're doing error bound, again, they might ask this first question at the beginning. Use the first two terms to approximate f of 1.1. So this is not the error bound part. The error bound part is the next part. Show the approximation. So again, remember that in Taylor Series FRQs, you often use the answer that you got in part A to do part B and C. So remember that this was my Taylor series. I'm going to rewrite it so that I don't have to have this other sheet. But it was 3 minus 2 over 1 factorial x minus 1 plus 2 over 9 over 2 factorial x minus 1 squared minus 6 over 27 over 3 factorial x minus 1 cubed. So remember that when you're doing this, you don't have to simplify basically at all. But when you start plugging in the numbers, it probably is better to simplify. So let's do this. Again, this first part is not the error bound part, it's just the approximation. So all we're going to do is we're going to plug in 1.1 into the first two terms because they said the first few terms. If they were really mean, they would ask us to do it in the first three terms. I've seen that before, and the fractions get really awful. So let's do the first two terms though, because that's what this question is asking. So we're just going to do this portion right here. So it's going to be 3 minus 2 over 1 factorial, 1 minus 1, 1.1 minus 1, sorry. 1.1 minus 1 is 0.1. So when I do this, because you don't have a calculator, I like to write everything in decimals. You do have to simplify the final answer. So it's 3 minus 2 times 0.1. But again, I like to write decimals, so it's going to be 3 minus 2 times 1/10. So that's 30 tenths minus 2 tenths. So I think we get 28 tenths. You might not have to simplify the fraction, but you need to make it at least a fraction, which is 14/5, yeah. But remember, that's not the final answer. Remember, for the final answer, we actually have to do the show the approximation is within. So that's the second part. That's the SN thing. So I'm going to write that. I'm going to write my basic formula. Because we were doing 2, it's going to be 2. Let's try to think about what everything is. So what is S? S is f of 1.1. That's the impossible thing. Minus. So I think that's actually wrong. I think it's B3, yeah, because it's S2. And what is S2? S2 is this number, 28 over, or 14 over 5. And then, as you said, this is S2. So this is going to be B3, the next one over. So this is the next one over right here, as you can see. And we're going to plug in, sorry, it's not 1.2, it's 1.1. We're going to plug in 1.1 into this guy, and basically we're done after that. So we're going to do 2 over 9, 2 factorial. We're going to plug in 1.1, and we're going to try our best. Again, it's nice to simplify, but 2 over 2 is 1. That n was the power, not the term. I think it's the term. I don't know who your calculus teacher is, but when you say like S2, you mean the first 2. When you do S3, it's the first 3. Or B3. So they might be wrong. But let's simplify this. It's 1/9, because these 2's cancel. 1 minus 1 is still 0.1, which is 1/10. And I need to square it, so I get 1 over 100, which is, and then multiply by 9, so it's 1 over 900. So this is really the number I'm looking for if you were trying to box your answer. And keep in mind, 1 over 900 is smaller than 1 over 800. So the most common Taylor series questions are like this, where they don't even just ask error bound, they ask the approximation. And usually this approximation, again, is in like part C of the frick and not the same part. So usually this is part C, and then usually this is part D. Should we keep going, or because we did really cover all 3 fricks? I think we had a fun time, in my opinion. Can we do the MCQ stuff? I mean, we can. And yeah, Lagrange stuff is kind of MC stuff. Or can you play chess? I don't know who these strangers are, but you kind of seem like nice people, so I can do some of these. Some of the MCQ stuff is like easy too. Okay, so I'm gonna do some of the MCQ stuff because it seems if people are willing to stay, I'm willing to keep going. So give me 1 second while I pull up a new document. No, I'm gonna play it during the first quarter of the Grizzly game probably. Because sometimes if the Grizzlies are losing, it takes my mind off it. I don't think Ja's playing, right? Is Ja playing? Is there PFP from 8th promotion? I don't know what that means. Sorry, I need to pull up something before we start. Yeah, so if no Ja, that means that there's definitely a chance we lose this game. But sometimes Scotty does better as a starter than... I don't know if Scotty's starting, actually. Is Kennard starting? Ja just gets injured randomly, so like he sometimes doesn't play. And also, it's about to be All-Star, so he'll get an 8-day rest if he doesn't play in this game. Okay, so we're going to do some Taylor Series questions. We actually didn't do some of them in the class that I was running, so let's get started. Actually, we might have done these. Okay, so let's say we do this question. So f triple prime of x equals x cubed plus x squared minus 1 or something. And we want to find the coefficient of the x to the fourth term in the Maclaurin series of f about x equals 0. All right, so this is our first question, like a multiple choice question. These appear on the multiple choice of the AP exam, sort of like, independent questions. So, again, the question is, do I use that factorial formula or do I not use that factorial formula? And hopefully you know that in this one, you would use that factorial formula because I'm given a derivative and I'm not given a Taylor series. I don't see like the sum of stuff with general term. So anytime I do this, I try to focus on that factorial formula. It's x to the fourth, and x to the fourth looks like this, f quadruple prime. So we have to write 4 because we ran out of derivatives. You plug in the number. So this is going to be a bad question. We're going to change this to minus 12x plus 1. So you're going to take the derivative and then you divide by the factorial. And this is going to be the answer. Okay, so the fourth derivative, so I take a derivative, basically. Let's first take the derivative. So keep in mind that I want the fourth derivative and they gave me the third derivative, so I have to take a derivative here. So it's going to be 3x squared plus 2x minus 12. And then I'm going to plug in 0 because that's the center point. So it'll be 0 here. So it'll be 3 times 0 plus 2 times 0 minus 12, and I get negative 12. But keep in mind that negative 12 is not the final answer. You still have to divide by the factorial. So the final answer is negative 12 over 4 factorial, which is negative 12 over 24, which is negative 1/2. So when you're doing these Taylor series questions on these multiple choice, if they give you something about the derivative, that means that it's one of the factorial questions. You try to like write out the terms. Here I only write out the x to the fourth term because they only asked about x to the fourth. Because they asked about x to the fourth, it's the fourth derivative divided by 4 factorial x to the fourth. They gave me the third derivative, so I had to find the fourth derivative by taking a derivative. It was power rule. I plug in the center point, so I plugged in 0, got negative 12. But remember, negative 12 is not the final answer for the coefficient because that's just the numerator of the coefficient. We do have to divide by 4 factorial. So that's that. A pretty standard, easy Taylor series question. Should I write on the back of these? Am I wasting paper? Can you like see it? I think we can write on the back. Okay, so the next one, as we move on, is pretty similar. Let's say the fourth degree Taylor polynomial is like 1/2 minus, I don't know, making up numbers here, 1/4 x minus 2 squared plus 1/8 x minus 2 3 minus 1/2 x minus 2 to the fourth. And what they're asking me is, so it's reversed as the previous question. They're asking me to find f triple prime of 2. Okay, so let's look at the old question. So in the old question, we were given some derivatives and we wanted to find the coefficient. And then in this question, it's the reverse. We're given some Taylor series, so we are given some coefficients and we want to find f triple prime of 2. So the way this works is the same thing. Just be wary that only one of these terms matters. I'm trying to find f triple prime of 2. So keep in mind that always the derivative number and the factorial and the exponent match. So the triple derivative will be on this term right here. So none of the other terms actually matter. So I'm going to write the general always in the formula. It's going to be f triple prime of 2 over 3 factorial x minus 2 cubed equals 1/8 x minus 2 cubed. No, y triple. No, y triple. Not sure exactly what that means, so I'm going to move on. So I want to find the triple derivative. The triple derivative lives on the x cubed term. And now, so in general, this is the formula for the x cubed term. And now I'm going to try to take the, and specifically for this one, it's 1/8 x minus 2 cubed. So I'm just isolating. These x's cancel because we're finding the coefficient. So it looks like all I have to do is bring over the 3 factorial. So then it's 1/8 times 3 factorial, which is 6 over 8, which is 3/4. No, sorry. The question is literally find the triple derivative. Like, that's part of the question. Or that is the question. They could have asked me the second derivative, the third derivative, the fourth derivative, but they just asked me the third derivative. So the third derivative, it's not because it's the third term, it's because it's the x cubed term. Like, it is the question. Find f triple prime of 2. I probably should have put a question mark. Yeah, sorry that you were made to look like a buffoon in front of 12 people. But hopefully that makes sense. These are the easy questions in my opinion, where you use the Taylor series formula with the factorials to find derivatives, or you use derivatives to find the Taylor series formula. So I'm going to move on. So there are some limit questions. So we can practice a limit question because that appears either on multiple choice or Fricks, and we might not have done that actually. So for example, let's first find the Taylor series of e to the x squared, and then which is going to be called f of x. And then we're going to find the limit as x goes to 0 of f of x minus 1 over x squared. We will do Lagrange at the very end. We might do like 2 to 3 more questions. Okay, so this question, again, could be on multiple choice, could be on Fricks. So e to the x you write out like normal. You memorize it. Then for x squared, you plug in x squared. So again, the first term is not affected. You can go, buddy. Like, it will record. So I'm plugging in x squared. Cool. And then I'm going to find this limit. So this would be the answer if the question was just find e to the x squared. So when you find the limit, you're not really supposed to do L'Hopital. But you do it the same way as we do previous questions. So we do f of x minus 1. So this is all f of x. So I'm going to replace e to the x squared with f of x, and I'm going to replace e to the x squared with this. This appears in Fricks sometimes, so just be aware of that. So this is my f of x minus 1 over x squared. So there's a long fraction bar. And then remember how you do these limits is this 1 will cancel out with this one. And then these x squareds will cancel out with these x squareds. So I think you're left with, these will go away. And x squared over x squared will be 1. X to the 4th over x squared will be x squared. You basically bump every exponent by 2. And then you plug in 0. And when you plug in 0, notice that there's still x's in these terms, and you're left with this 1. So the answer is 1. Again, that appears in Frick sometimes. So you might not be familiar with that question, but we've done it before. Yeah, I did subtract 1. So it's e to the x squared is right here. I subtracted 1. When you subtract 1, you only subtract 1 once, and it just canceled out with this first one. And then you divide everything by x squared. It's because it's Taylor series, so they don't want you to do L'Hopital. So they can construct the question in a way where you can't do L'Hopital. the x squares cancel because like it's x squared over x squared, x to the fourth over x squared, x to the sixth over x squared. And when you do this, the way it works every single time is you'll still have an infinite number of stuff, but when you plug in the number 0, all of them go away besides the first one or the second one. I actually don't know the person's name who just chatted. Hopefully this makes sense. Again, it's a frick. The first one is gone, and then you divide by x squareds. And then you plug in the number, and you should get a number. But the first one's gone. Yeah, we want... Oh, so, Cubba Hutch. The first one is gone, as you said. And then this second term divided by x squared becomes in 1 by coincidence. So this one right here is not the same thing as this one. It's actually this term right here. Yeah. Okay. Let's do some other questions. Remember that one of the easiest questions on the AP exam is just like recognizing what Taylor series it is. So like, for example, I'm going to write 2 questions and you can try to do it. It's only a one second question, but it'll be like 1 minus, I don't know. Trying to do math in my head. Wow. I think it's this. So you can try this one, and then you can also try this one. So remember, these are the 1 second questions. You try to recognize what Taylor series it is, and then you try to recognize what number is getting plugged in. There's really only one thing you have to write. But as you do this, I'm going to try to find a good Lagrange question to do, because somebody has been quite insistent on asking a Lagrange question. So let's do these. So again, you try to recognize the Taylor series. What the heck is 5 factorial? Oh, it shouldn't be 5 factorial. It should be 6 factorial, right? Sorry. Yeah, so the first one is cosine of 2, as she said. No, sorry, it was supposed to be 6 factorial. You got it. You're so good at math. It's cosine of 2 because it's all the even ones and it's alternating. 2 factorial, 4 factorial, 6 factorial. And you just see what number is getting plugged in. And 4 is 2 squared, and 16 is 2 to the 4th, and 64 is 2 to the 6th. So it is cosine of 2. Same thing with the next question. And the next question, you recognize it's e to the x because you're not alternating and you're not skipping any. So the answer is e to the pi. Okay. Maybe we should conclude right now with a Lagrange. So I'm copying this from my notes. But you take P4. Our center point is going to be x equals 1. Sorry, it's going to be x equals 0, not 1. And then we have this formula right here. So they give us this formula. Whenever you see this absolute value thing of the derivative, it's probably Lagrange. And then they want us to show that f of 1 minus P4 is less than k. And they say find k, where k is the smallest error bound. Okay, so let's do this as people are getting tired. So the way it works is the same as normal. Lagrange error bound is really similar to the original, like alternating series error bound. What it is the next derivative, so it's the 5th derivative. Because the term is the 5th one, so it's like 5th derivative divided by 5 factorial x to the 5th. So fifth derivative divided by 5 factorial, x to the fifth. And really all we're going to do is we're going to try to find this number right here. And I chose fifth because 4, it's the next derivative after 4. So what you're going to do is you are going to just always keep the factorial. That's the easy part because it's already a number. You're also going to plug in a number. Thankfully that we're plugging in 1, so it's 1 to the fifth. And then we need to plug in a number for this derivative. And what you do is you look at this formula, and this will tell you what number to choose. So when you plug in 5, because we're finding the fifth derivative, it'll be 5 over 8. As so. And then all you do is you simplify this number. It's going to be 5 over 8 times 1 over 5 factorial. So I think it's 1 over 8 times 1 over 24, which I'm not going to simplify, but it's some number. I can do it, actually. We actually did this in class, I think. We got the same number, 1 over 102. I think. But that's how you do Lagrange. Hopefully that makes sense. And hopefully all of this was good karma for the Grizzlies. But really focus on the Taylor series. I think the one thing we didn't do is the rational function stuff. Just keep in mind that's geometric. But I think we did the majority of everything. We did a lot of airbound hopefully today. Just look at the next one over. Don't include the negative. Plug in the number. And then for some of you, remember the big question you're asking yourself is whether you use the factorial formula or you don't. And if you see something like fn whatever equals something, you use the derivative formula. But if you see like if they say here's f of x and here's the sum and it's like x to the blah blah blah, then you wouldn't use the factorial formula because you already have a Taylor series. Or if you see sine of x, cosine of x, or something like that, you wouldn't use the factorial formula because you already have a Taylor series. But hopefully you just work slowly as you do these Taylor series. Remember, if you're taking derivatives, just do it term by term, power rule, and things like that, and so on. But hopefully everybody enjoyed this. I think I had a decent time. But I'm going to go play some chess and watch some Memphis Grizzlies. But thanks for watching.